Scenario: a motion detector records a 0.2 kilogram object in free fall on an unknown planet on the graph. The question: what is the gravitational field strength around the object on this planet? Please understand that the gravitational field strength is equal to the object's acceleration due to gravity. G, which is the gravitational field, is equal to AY, which is the object's acceleration due to gravity. Because the object here, it is falling down during free fall, there is a gravitational field around it that is pulling it. The AY can be seen by the delta y over delta t, which is just the slope or the rate of change of velocity as a function of time. You can expand this out to v minus v naught divided by t minus t naught. What you need to grab here are the two values. The first value that is grabbed here, it is at 0 time, it has 80 meters per second, and at 8 seconds, which is its final second, it has 0 velocity. Therefore, you can now plug it into the equation, solving the gravitational field, which is the object's acceleration due to gravity in the vertical direction, is equal to 10 meters per second squared. The second question: what is the force due to gravity exerted on this object by this planet? So here, this object is on this planet. While it is being pulled down at 10 meters per second, there is a force here. The force that is acting is the force of gravity. Force of gravity is defined by m times gravitational field, which is g. Plug in the values, you get 2 newtons. That is how much the gravitational force is exerting on this object.